So again, now that the recording has started, the homework for today is the same as what you maybe wrote down for Tuesday. So if you, like me, don't want to erase a bunch, you're not ready. I can look at you and immediately tell that you're not ready, because what should you have out? You should either be filling your plan book or you should have graph paper out ready to go. Guys, please make sure we're all getting ourselves ready in every class. Like, you know what you need to do. It's almost December. Like, we are halfway through November. We're almost halfway through the school year. We try to keep things fairly consistent when we can. Math class doesn't really change. We have an assignment for the night, and we're getting out graph paper to take notes. Moving forward, and I need people to hear this. I plan on generally collecting homeworks either with a mastery, like if we're having mastery on a Friday or something like that, I'll probably collect homework with that, or just on Tuesdays. So like yesterday, if this got communicated by the sub correctly or not, these 4 assignments, 333, 3 closure, 411, and 412, all of those are from last week or older, right? So you should have them done. So if you didn't have them done by Friday, you had the weekend to get them done. They should be done now. Get them turned in today by AO. Remember when I say this, because language arts people had issues with Discovery Day plan. Get it turned in today by AO. I'm probably going to put those grades in math during my planning period, block 3. Okay, so moving forward, anticipate the previous week's homework to be collected on Tuesday. Because I don't like collecting on Monday. I feel like that's kind of like playing gotcha. But I will then on Mondays tell you what is going to be collected on the following Tuesday. But you can just assume whatever practice work from the week before. I'm going to try to keep to like 4 or 5 assignments at a time. You're going to use straight edge today to help you with making graphs. So either a protractor has a straight edge, or the shapes templates have a straight edge, rulers have a straight edge. Even the edge of your book, Nathan, come on. You are going to need a straight edge. So if we, hey guys, I really don't want to compete with you today because I'm still fighting like a headache and some congestion and everything. If we think back to chapter 1, now before I have you guys copy this table down, like we want to think about this before we copy down. We think back to chapter 1. We did that activity where we stacked pennies, right? When we were trying to measure how tall they were, and we found a constant multiplier. We found how many pennies it takes for each centimeter, right? We found this out. So that ties back in. Notice what we're talking about with like CPM, we kind of circle back around the same stuff again and again. That relationship, well, how tall would 0 pennies have been? 0, right? So we have our 0, 0 point. What happens if I double the amount of pennies I have in my stack? Does my height double?
No.
Think about it. If I have 10 pennies compared to 20 pennies, would 20 be twice as tall as 10?
Yes.
Yeah, sorry. For those of you that thought double 0, yeah, you're right. Like if I double 0, that. But if I have an actual stack of pennies, right, and I double that, the height doubles. So let's on our graph paper. Now don't copy down the numbers. Okay, just copy down the height of tower and the number of pennies. Put the top of the T-chart. So you just put height centimeters. Like you don't need of tower. You just put height centimeters. And then on the other side of your T-chart, number of pennies. Do not copy their numbers because their numbers are out of order and that drives me crazy. Now, what I want us to do is make our own table that starts at 0, 0, right? Because we know 0 pennies would be 0 centimeters tall. Now, be careful. The left column is your height, right? Now, who can rack their brain and kind of shake loose some old information? How many pennies did it take to make 1 centimeter of height? Do you remember, Eva? It was more than that. If we can't remember, we can look right here. If it took 28 pennies to make a height of 4. It was 7 for each. So the next thing I want you to put on your table is 1 and 7. And then fill in what we would have for like 2 and 3 and 4. Do like all of those. Then we'll start to skip a little bit. And I'm going to flip my screens. So do 0, 1, 2, 3, 4 just to get us started. I'm going to really abbreviate this because now I got to try to catch up with you guys. So we had centimeters and number of pennies. So we had 0, 0. 1 was 7. So what would 2 be if we double the height? 14. What about 3? 21. 4?
28.
That one was given to us. But now, and I'm just going to do a squiggly line, make another tower. Or another T-chart. You can continue yours, but I don't have screen. So if we look at the centimeters compared to the number of pennies and we jump now, what about like 12 or 15 or what about something really weird like 174? So with your team, I need you to answer these questions. And then what about any height? What would go over here? Or what if we don't know what height we're looking for, but the height will be X centimeters? So talk with your team. How do we figure out the 12, the 15, something crazy like 174? And then how would you figure out X centimeters for the how many pennies? So talk with yourselves. It could be like a minute or two. Oh, I got to pass a couple things back. So yeah, just talk with each other. Is Casey not here today?
I don't think so.
Okay, so I already have these in my grade book. You don't have to turn them back in. You can turn them back too. Okay. If we try to pull in another vocab word, or try to think back to another vocab word, what is our unit rate here? What is our unit rate? And we could actually have 2 different ones. Eva?
So, I'm not sure this is right, but like 7 pennies per everyone.
Ah, so this is the nice one. Please circle this on your table. That is our unit rate, because it is 7 pennies per centimeter. So we could actually make a really nice statement based off that 7 pennies per centimeter. We could say the height of the tower, or sorry, not the height equals. My bad if you wrote that down. We could write the height equals, but that's more complicated. Height of the tower would be the other unit rate, which would use 1/7 actually, because we know each penny was about 1/7 of a centimeter. If I talk about the number of pennies, like at our X height, at our any height, I'm going to have to start to pay Eva if I just keep calling her. So, Adrian, what do you think about the, like, how I could figure out the number of pennies I needed? What if I know the height? Like, I say something. So if I'm plugging in the height here, so this will be whatever the height is. If we look at our table, how does the number of pennies always compare with the height? So what we're saying is, how do I go from height to pennies, or pennies to height? Like, what is that relationship?
Times 7.
Ooh, 7, right? 1/7 or times 7, right? Either 1/7 of them going over there or times 7 over here. The number of pennies is 7 times whatever our height is. So here, where we have x pennies, or x as our height, sorry, not x pennies, x as our height, what's our number of pennies? Anybody? 7x. Because to get the number of pennies, we just do times 7. So what is this number right here for a height of 12 centimeters?
It's
84 pennies. What about the 15 centimeters? 105?
Yep. 1,218.
1,218 pennies here. If I do times 7. So what we need to be able to recognize is if all of these are times 7, times 7, times this, still, even if the input's just x, is just times 7.
Yep.
So then if we go to graph this, what would make our life really easy? Sorry, I didn't want that. I wanted this.
Please excuse the interruption. Could I have Sunny Nutter to the office? Sunny?
Draw an x and y axis on your paper real quick. I promise I'll make this one easy.
how tall is
Whatever. A few.
What's a few? 3?
Like a 10 by 10 is always safe, but like if you at least have like 7 by 7, we're probably okay here.
707.
Like 7 by 7. At least 7 boxes each direction. If I make my bottom height,
That doesn't work. Maybe you have to always do the left side for height.
I mean, we can do whichever we want. Actually, it depends what we're talking about, input and output. So you have a really good point here, Ava. So you said, don't we normally have to do height as our y-axis? A lot of times we do, but here, if I make my height my x-axis, my height will determine how many pennies I need. Right? So we're going to say that the number of pennies is dependent on height. So if we make this pennies, if I go to a height of 1 centimeter, how many pennies do I need? We have 7, right? We have it on our table. What if I want to make all my points line up perfect? Then I make my scale, as this is why I fell in love with math. I can make my graph look really, really nice if I just force it to be that way. I know that 1 centimeter needs 7 pennies. So I make this 7. What would my next scale be? 14, then 21. I just go up by 7s, and we have a really nice graph where we will get a straight line from the origin through all those points. So way out here, you have some height. We had some random height of x. And we go up to our value on our line. That would be 7x. Right? We can use our unit rates to make our graph really nice. Otherwise, we're going to have to be like in between boxes, which sometimes happens. But if we want to make the graph really nice, we can just use our unit rate. Questions on this? And you could fill in a few more heights if you want, because we would have like 3, and 5, and 7. Is this graph proportional?
Yes.
Yes. We should be able to start to kind of recognize that quickly. What 2 things do we look for on the graph to be proportional? Not necessarily the table, but a graph.
So what I look for is like if it starts from that one bottom and keeps going like
gotta start at 0, 0, right? So one of the big things we look for is this point right down here. Does it start at the origin? And then does it move as a straight line? Right? So I gotta start from here and go straight up. If I change my angle, it's still proportional. Maybe I use dimes instead of pennies or quarters instead of pennies. Maybe I change like this. That's still proportional because it's a straight line coming off the origin. Now if I do this and then I change, is that proportional? No. So this green line now would not be proportional because it changes the angle. But if I just have the line that we just graphed, we are good. We are proportional. Questions on that one? Because it's the creative ones. All right, so now, and I'm going to give you a minute to do this, I want you to set up this graph on your paper, because again, I'm trying to save copies. So I'm going to draw it up on here, but I need you guys to do it exactly how it is. So 4 boxes should be 1 pound of cheese, like right down here. On the vertical, so I'll pull this down onto this screen for a moment. So check it out. This is what you want to pay attention to, this bottom corner to set up your graph. Each box on the x-axis is going to be worth a fourth, right? So 4 boxes makes 1 pound. This is going to be pretty wide. Like this is 20 boxes wide. So like this is not going to be a small graph, it's going to be kind of big. And then it needs to be 20 boxes tall because each box will be 1. And actually, it'd be better if it was taller. So if you can get to 25, that would be good. Like you could flip over your paper if you want, just to be able to fit the whole thing on. We're going to do a decent amount, and then we're going to have 2 T-charts that go with it. So somewhere above, below, beside, leave some space for 2 T-charts. So this is what you're trying to copy. And we have pounds on the bottom and cost. You can just put a dollar sign on the y-axis. So I'm going to put that up on the TV. 20 by 20 if you can.
I thought you said 25 by 25.
Well, 20 by 25 would be good, but so 25 tall is the max height that we go to. 20 wide takes us to our 5 pounds of cheese, but even wider would be better. Really just make it like as big as you can for your paper, probably.
I made it 25.
Oh my gosh, I just lost my count.
So just make it really big. And then once you start adding tick marks, then you can fix it. And then make a T-chart for mozzarella and make a T-chart for Havarti, which is a great type of cheese. My wife's favorite cheese has mushrooms in it.
What?
Yeah.
I like blue cheese. It is moldy. Will you like blue cheese? Yes, I love blue cheese.
Mozz, we can abbreviate M-O-Z-Z. Havarti isn't really long enough. We can just write out the whole thing.
Blue cheese is too thick. It's cheese. Yeah, it's too thick. But it's cheese.
Hey, so please make sure you have 2 T-charts. One for Mozz, one for Havarti.
Very big graph.
I have.
But we just save 25 sheets of paper by just doing that. And graph paper, like notebook paper, uses less tree than like a piece of computer paper, because that comes down to the stock of the paper. Have you ever heard of like card stock or something like that? So that's why I would rather have us use your notes paper as opposed to computer paper, and it saves ink too, so it just saves us a bunch of money different ways. So let's look at what Casey tells us. Casey loves cheese, and she actually orders it because that's how much she loves cheese. So she bought 5 pounds of mozzarella for $15. So down here in my Mozz graph, 5 pounds, we can go ahead and put in $15. Her Havarti, she bought 3 pounds.
Havarti, what the heck is that?
It's a type of cheese. Havarti is a type of cheese. just like cheddar and Swiss, and it's just a fancier kind. There's a lot of cheeses. She bought 3 pounds for $7.50. Here's what I need you and your team to do. Fill in the rest of these tables. All the way from 0 to 5. And then all of your prices, and over here, all the way from 0 to 5. And fill in your prices. Fill in those tables with your team. With your team. Nope, with your team. Talk with your team. Nope, you shouldn't need one here. Now, if you're still working on your graph, that's okay.
Okay, Mod's easy and obviously 3, 6, 9, 12.
It's from next week.
Well, that's the best way to use the paper. Like, if you think surface area, if you think about the math of why we did this, it's the most efficient use of paper.
I don't what?
That's very cool. I don't even know what to call that shape. It's like,
A triangle.
well, but it's got 4 different triangles. Like, it's a triangular pyramid, actually. Yeah, it's a triangular pyramid. All right, Casey's out. Eva has already been running class. Greta, if I go to find the cost of a single pound of mozzarella cheese, how can I do that?
Obviously,
Greta, sorry, what did you say? Couldn't hear. Times it by 3. Oh, you're saying it is 3.
yes.
How did we get the $3 here? Yeah, guys, if you are looking for unit price, and you might want to make this note somewhere in your notes, unit price will always be price divided by quantity, which we abbreviate with QTY. Your unit price, your price of 1, will always be price divided by quantity. So Greta said, well, if we do 15 divided by 5, we get 3. So to find all of these prices, I can just keep adding 3. So we get 3, 6, 9, 12, 15. That works out perfect. And of course, 0 pounds would be 0. So then, Joey, what about the price of 1 pound of Havarti?
That's the one that I needed a calculator
No,
for.
I know it.
All right, help us out, Isaac.
2.5.
Yeah, $2.50. If we take 750 divided by 3, so this is 5. Please make sure you have your table completely filled in. Now, go plot these points. Do one complete table, plot those points, and then do the other table, plot those points. We're going to try to connect them. Remember which one's which, because we're going to label our lines like this is the Mott's line or this is the Havarti line.
What? How are we supposed to label that?
So, I'm glad you asked. If I were to go do this, maybe right beside my point, I'd put a little H or I'd put a little M. So if I go to do this and I look at my table, I'm going to flip this up to the TV.
Can I make 2 small charts?
No, we're going to do them on the same one on purpose. Yo, so stick with me. Come here. If we go to do Mott's first, I'm sorry that shrunk down. 1 pound of Mott's was how much?
$3.
$3, right? So I put that there, and maybe I put like a little M. 2 pounds of Mott's was 6. 3 pounds. Now, if you have different colors, you could honestly just use colors here. 4 pounds. Then do your Havarti.
Joey's like, I'm so
Fine.
confused. Yeah, I ate.
Then do your Havarti. What do you mean we're just plotting points?
What?
That's why I'm walking around trying to give you guys time. We're plotting points.
Marshmallow costs more than
We're gonna
actually
we're singing God is One next round.
Where's your graph? Bring it.
Oh,
No one can sing on that.
But you don't have any points on it.
What?
Look, keep going. Why are you waiting for me?
How come I have to stop?
But now you're waiting for, well, keep going. Put your Havarti cheese
Wait
points
a
on there.
second.
I don't do
I
that.
made my graph
This
wrong.
other table. We need to plot all of those points as well.
That's not nice.
What do you mean, yeah, but?
That's just a
There's no but.
That's why I got made fun of on swim team.
That looks so
So that's why I got made fun of on swim team.
You had no butt.
Yeah, they made fun of me.
You
I
had
got
That's
bullied.
nice. Why would they make fun of you?
Well, I mean, there's a lot of reasons to make fun of me, but.
There's a lot of reasons.
No, there isn't, Mr. Hudson.
But I already do the work.
Why would there be reasons to make fun of you?
They would joke that I had no butt and therefore I should go faster. But also, when I would swim, I don't kick very well. My feet just don't do much. My arms do most of the work. So then they would joke I looked like a snake as I went through the water. Because my feet were just kind of like dragging behind me. Because when you freestyle, like who swims in here? I know Worthington has a pretty good swim club. Yeah, so like when you freestyle, you're supposed to be kicking like this, right? Mine would be like little kick, maybe kick, maybe kick this. Maybe
How
like,
far did you go?
I did hundreds, 200s, and occasionally a 500, but not often. 500s are about a third of a mile, if you want to rate that to like how far you're actually going in the water. So, guys, if this, and I threw this in Smartboard, so I had a few different tools. If this is what we have for mozzarella, and I go to do my Havarti, my points are going to end up lower. And I heard somebody say it. Why is the fancy cheese cheaper than the mozzarella? Well, there's different kinds of mozzarella. And Havarti is just a different kind. It's not necessarily fancy, quote unquote. So if I go to 1 pound of Havarti, that's only $2.50. 2 pounds is $5. 3 pounds is $7.50. What do you notice about the distance between these points? They're getting farther apart. And if I go and I try to connect mozzarella, I can make my line way out to here.
Wait, I'm so confused.
And if I try to connect Havarti, I'm going to answer all your questions here in just a second. I just want to show you what we're heading towards. So then once you get your line graph, please put an M equals and an H equals. An M equals for your mozz, H equals for your Havarti. I have a feeling we have an issue here. You did not scale your graphs as I asked you to. Just like we were talking about this morning, with some people are following directions and some people aren't. I said very clearly multiple times, 4 boxes for 1 pound. Look up there at my graph. My 1 pound does not happen until 4 boxes in. So whether you remake your graph or not, just so you're aware, like your graph's wrong because you didn't listen to directions. Okay? So that's an issue.
I didn't mess it up.
Oh, that needs to go all the way down to the 0. Yep. Your line should connect all the way down to the 0, 0 point.
That's what I did.
Sorry that my lines look like they're slightly off of each other. That's just Smartboard. So I can fix it if I use my mouse. If I use my mouse, I can get that corrected. So I can put that right where it goes. And then we can formalize the relationship we see here with something that eventually we will want you to know is the slope equation. If we talk about the cost of mozzarella cheese, how could we calculate any amount of weight? Hey guys, if you're playing with your ruler or your template or whatever, please put that down. I teach 7th graders, not 7-year-olds. This is not a mask. It is a shapes template. I see some people fighting that urge. If we talk about the cost of any weight of mozzarella, it's like, Aiden, what if I asked you for like 87 pounds of mozzarella? Like, you're not going to add 87 times.
87 pounds? You need that much cheese?
I'm making dinner for everybody. But how could I calculate it? How could I calculate the price of mozzarella for any weight? What would I do with the weight? Like if I tell you 87 pounds. You want to phone a friend? It sounds like Isaac knows.
Yeah, Isaac, go ahead.
Multiply by 3, right? We said every pound is 3. So guys, your unit rate serves another purpose. Your unit rate is also the multiplier. It's 3 times whatever your weight is. Your price of mozzarella is 3 times whatever your weight is. What about Havarti then?
2. Just kidding.
2.5 times whatever your weight is. So please make sure we have those equations written down. This, and guys, this is starting to be on your masteries and things I expect you to know. These values are what we call the constant of proportionality. So you might want to write that down here. Those are the constant of proportionality. Sorry, there's a Y out here. It's just kind of dark. Maybe we'll shift this over. Yep. Constant of proportionality.
Oh my
Do we have that written down, Nate?
Okay.
Dude.
What? Are you checking me?
I don't know. Am I? Are you doing what you're supposed to be doing? You should be able to answer that question.
I literally just put down constant proportionality. So, I crossed the bridge.
So, how can we use this graph? I'm moving in the book, but we said that we know that these are proportional because it's a straight line. We have a 0, 0 point. The angle doesn't change. All that stuff. But the reason that we do this sort of thing, and guys, computers do this without you ever realizing it. Like, there's a bunch of graphs involved in all the games you play. There's graphs written into the code in situations where it's like, how long do you hold on a button? How much pressure do you give it versus what it responds with? All graphs are input-output. Something comes in, something goes out. Our input here, and if you're like a rock star, you might want to write down these couple things. When we talk about graphs, we always have an input and an output. Input is your x-axis. So input here is how much do we buy? All right, how many pounds do you ask the butcher or whoever, I don't know, the guy at the deli counter, I guess. I don't know what the guy who cuts the cheese.
The butcher.
The butcher's the guy who cuts the meat, right? That's the butcher, but
Yeah, the butcher kills
the butcher
the
probably cuts the cheese too. And then the y-axis is always your output. So you have an input and an output. Here our output is what do we owe, right? How much money do we have to pay? Our input is how much are we buying. The output can't just change on its own, right? The input will change with it.
The output's 0.
Another really easy way to look for is something proportional. So on your paper, please just write down the word proportional with a question mark. Like, I'm trying to make the notes as short as possible, but just write down the word proportional with a question mark. It's number 36 if you care. When we look at a table, and here's all I need you to write now.
Double X, double Y.
If we look at a table and we're trying to determine if something is proportional. If we double the value of x, now 0 doesn't count, as we talked about earlier. Like, you can't double 0. You can try to, but nothing happens. So 0 doesn't count here. Okay, so maybe if you're gonna get screwed up on that, maybe make a note that says like not 0. But if we double the x, the y should also double. For a graph, we're just looking for our 0, 0 point and straight line. Says if you have these two different ways that we check for proportionality written down, you are far ahead of what we're going to be asked to show on a mastery. Now, I had to shift some things with being out yesterday, but I think we will be having a mini mastery on Monday. And that's not my normal. I don't like ever put masteries on Monday, but I was going to try to do it this Friday, but now we had to shift the calendar a little bit, and next week's really awkward. We don't really have normal classes on Tuesday because of the Turkey Bowl. So be ready for a mini mastery on Monday over proportional relationships. Also, be ready. I'll still take it on Tuesday. Give me your eyes. I got some people that I think care more about their eraser than they do me. I'm going to collect this week's homework next week. I'm going to ask for it on Monday, so if you have it, awesome, turn it in. If not, I will take it on Tuesday, but there's no specific math class, at least to my knowledge. So please, next week's going to be different. So if this is going to wig you out, you might want to write down a note that Monday we're going to have a mini mastery that it's going to be manageable to get done in one day, and then I'm going to expect you guys to turn in your homework. If not, just like anything, we're just going math is a missing, and once you get it in, it will change. But try to stay on top of it. You had a work day yesterday. You should have kind of gotten ahead. We slowed things down a lot these past couple weeks. Natalie?
Bowl is Tuesday.
Yes, we go bowling, and there's no school on Wednesday, no school period. And teachers, we have it as a professional day. It counts as a day actually, but it's a professional day for us, comping the fact that we had conferences. I'm going to be here till 9 o'clock tonight probably, with conferences and PTSA meetings and everything else. So knowing this, look at 37. I want you and your team to analyze. Actually, it would be good if you would write down the tables from 37 really quick. So 2 different T-charts, X and Y. If you would, and obviously I'm not going to come around and check for it for everybody, but it will help you if you write these down. So my advice is write these down. But with your group, discuss, is A proportional? Is B proportional? How do we know? I only have time to give you a minute to talk about this. So, is A proportional? Is B proportional? How? And notice they don't show the 0, 0 point because they're trying to not confuse you.
Oh, wait, no, it's not.
It's just asking you, is it proportional? Then, if it's proportional, we can write some sort of special relationship. 30 seconds. Hold on. 10 seconds. Now, if you're going to answer for me, can you then tell me y equals something x? If it's proportional, we should be able to write a statement like that. How y relates to x, using that constant of proportionality or that multiplier. All right, Aiden's got the answer for us here. Aiden, what do you think about A? Are we proportional? Why?
You're just multiplying by 2.
What do you, here or here?
Every single one.
Ah, so Aiden is saying if I look at how y and x relate to each other, times 2, times 2, times 2, times 2, y is double your x. Now the other thing he checked, at least I'm assuming first off, is if I double my x value, Do we double our y?
No.
No.
Yeah.
Why?
A lot of you guys are trying to gut answer. Don't gut answer. Think. Did this double?
Yes.
Yes. Did this double?
Yes.
Then we know it's proportional. As long as that relationship always works, which I can check it again. What if I triple? Do I triple? Yes. I double here. Do I double here? Yes. So if we step over here,
You're just adding one.
all right, so boom, boom. This is all plus 1. So you're saying y is x plus 1?
Yep.
Is that proportional?
No, it's
Nope.
No, because is my x doubling? Yeah.
Oh, what?
Is my y doubling?
Oh,
No.
No, sorry, no.
3 is not double 2.
no.
2 is double 1. This doesn't work. I can try a different one. Right? What if I go from 2 to 4? Okay, that doubles. Does this double? No. So guys, this equation is actually y equals 1x, but this right here, that plus 1, that's why we're not proportional. Notice over here, it doesn't add or subtract anything. So really quickly, because I'm out of time, so you can start packing up, but please give me your attention. We can look at graphs the same way. Why is this graph not proportional? Well, both reasons, right? No 0, 0, no straight line. Why is this graph not proportional? It just doesn't have the 0, 0. This still doesn't have the 0, 0. This, not a straight line. Right, so we can investigate graphs the same way. All that I got for you today. Have a great day, guys.
Wednesday. Right.